I'm Jonathan Tomkin from the University of Illinois. If we want to understand how to efficiently allocate our resources to address important issues like the environment, it's worth knowing a little bit of the underlying mechanics behind environmental economics, which is the study of this very problem. It's an axiom in economics that if something costs more, we want less of it. Let's think about this graphically. Let's take apples as an example. You like apples. You're at the store. How many do you buy? Well, it's going to be partly a function of how many apples you need, but also partly a function of how expensive the apples are. So if apples cost 25 cents each, that might mean that you buy 8. But if the price of the apples goes up, let's say it goes up from 25 cents per apple to $1 per apple, you might only buy 2. You'd rather use your money for something else. So for example, if you're buying this apple as fruit for a snack, you might decide, well, the pears are now a better bargain, so I'll buy a different type of fruit. Or maybe you'll end up buying a granola bar or something else entirely. At some point, buying the apples won't be worth it. They'll just be too expensive. So you'd rather hold on to your money. Now, if you think back to our very first lecture from this week, you'll remember that that means that you're trying to maximise your net utility, or your own welfare. That is, you want to make sure that the benefits of buying the apple outweigh the costs. Okay, so far so all simple. Maybe the line isn't exactly straight, but it's always going to slope down. That is, as the price goes up, we're going to want less of a particular item. Let's think about it from the apple seller's point of view. They have a very different incentive to you. They want to sell as many apples as possible. Okay, so maybe that's something we've got in common, but they want to sell it for the highest price that they can. Now, if you're a farmer producing apples, producing more apples is going to cost you more money, right? So you might have to plant more trees, you'll have to buy more fertiliser, you might have to water more and so on. So it costs more to produce more apples. So it's only worth producing lots of apples if you can get a higher price. So it's only worth growing 2 at 30 cents, let's say. But if the price was higher, let's say it was 75 cents, it'd be worth growing 8. So you can see in this case, there's an opposite trend in the relationship between how many apples I want to produce and the price of those apples. So then we can ask ourselves, where do we figure out how many apples are bought and sold? And at what price? I've drawn a whole bunch of examples here. We have 4 points on this graph. Clearly in each of these cases there might be some agreement or there might not, but how do we find the place where the buyer of the apples and the seller of the apples can agree that this is the place that they want to be? One way to think about it is that the price will go up until the producer makes the most money. There's no point making more than this, because even if they sell each individual apple for more, they have to sell less apples, and so their total profit is lower. So if we look at it from the buyer's point of view, right, the consumer, we want to pay the lowest price, if you like. And as the price goes up and up and up, the number that we will buy goes down and down and down. So the amount increases until these two lines intersect. And at that point, we find the most efficient meeting between the price of apples and the quantity produced. So the two curves intersect, and that point tells us how much is produced at Q0 and at what price, at P0. Now, everything under this orange line is bad. That's a cost. It's a cost to produce, for example, the apples. On the other hand, everything underneath the blue line is good. That's the benefit. That's the reason why we want to exchange our money for an apple. The apple is worth more to us than it is than the money that we're holding in our hand is. So as long as the area underneath the demand curve is bigger than the area underneath the cost curve, then we have a net benefit. So this is the benefit of the transaction less the cost. So in this case, the benefit is the apple and the cost is the effort needed to make the apple, to grow the apple, fertilise, water and so on. And so in this case there is a big area that is a net positive. And so it turns out in fact that finding this point where the two lines intersect and using that creates a big benefit not just to the producer who manages to sell their apples, but also to the consumers. Remember, you would have only bought a couple of apples for $1, but here the price is much lower. It's less than 50 cents according to the numbers that we used for the apple example. The difference between that $1 that you might have paid for those 2 apples versus the 50 cents you're paying here is known as the consumer surplus. That's another concept from economics. And that's a great thing for you. That's the net benefit for you personally from buying this apple. You get the apples cheaper than you would have otherwise had to pay for them. You were willing to pay $1 for that apple and you end up paying just 50 cents. So clearly you're 50 cents ahead of where you would have been outside this framework. Similarly, the producer makes a profit as well. He makes the product for less than the final cost. That's his profit. So since the first apple didn't cost nearly as much as the price paid for all the apples are paying for around that 50 cents mark, then that first apple, he makes a clear profit of around, say, 25 cents. If it only cost him 25 cents to produce that first apple, but you're paying him 50 cents. So both sides benefit from this transaction. In fact, you can actually use this sort of curve and make a nice, neat cut where around half of it goes in surplus to the consumer and about half goes as profit. Now actually, exactly how much goes as profit and how much goes as surplus depends on the shape of the curves, but in principle, both sides benefit, and that's why this transaction occurs. So the market is great, except when it's not. Remember when we talked about market failures? An example of a market failure is if there is a social cost that is not accounted for by this transaction between the buyer and the seller. So remember when I'm driving my car, I've got a negative externality, I'm doing a negative impact on the whole planet by emitting carbon dioxide. So this is known as a market failure. To extend that example, let's think about oil. If we drive or fly or use oil in any way, we benefit ourselves, we benefit the producer just under that framework that we've just looked at. There was a surplus for the consumer and a profit for the producer. But the bystander from that transaction may be experiencing a number of negative impacts. Exhaust, like in smog, congestion, noise, and of course the carbon dioxide. So the real cost is higher than this curve would suggest. And so this cost curve we might describe as, say, a private cost. So that's the cost to the people involved in the transaction. But it neglects that social cost, that cost to the world as a whole, or to, bystanders on the street. This means that if we're not accounting for the real cost, we actually should be using a different cost curve. The real cost curve is different, it's higher. So the real cost of producing an apple or selling oil or any other transaction really requires that we take into account all of the externalities. Sometimes they're positive, but often they're negative. And if they're not included in the final transaction, then that means that the market can agree on a quantity and a price that does not maximise the social welfare. In other words, it's not efficient. Now, these additional costs don't change the demand curve. If we subtract the area under the new cost curve, we can see it's much larger than it was before. And in fact, in this example, there's a large red wedge, this red triangle, which is all negative. This is an area where the demand, that is the benefit, is lower than the real actual cost when we take into account those negative externalities, those damages done to the environment in a wider context. So this is a market failure. The market is operating as it's supposed to, but because it's not accounting for that wider environmental cost, that social cost, we're actually making all society poorer instead of better off. Instead of having a higher net utility, we have a lower net utility. Notice that we can actually remedy this. All we have to do is move back up the demand curve to where the real cost is. If we do that, we completely remove that big red wedge, because we're now taking into account that difference between the private cost, the cost of producing a good, and the total social cost. And so we're left with a smaller area, that smaller green wedge, that smaller green triangle, but that's still a good because the total demand is outweighing all of the negative effects, including the environmental effects. So unless an environmental pollutant creates infinite damage, there is some point where being able to emit a little bit of it is still worthwhile because it does promote things that are very important to people. So if we can save a life by emitting a pound of carbon dioxide into the atmosphere, we would do that because we might judge, well, that's still, the net benefit of that is still higher than the social and the private costs of doing that. Notice in this case that if we do use the real social cost curve, the quantity supplied is lower and the price is higher. So the question then becomes, how can we use policy to move from a place of market failure to get that total social net welfare at its highest point? Well, there are two main ways. Firstly, we can use a cap. This might be an example of a command and control legislation. We mandate that only so much quantity is produced. And so here we'll have a limited quantity produced because of the cap, and that means that each item produced will have a higher price. Now, if you make this cap by, say, selling producers the right to pollute, right, so we give certain producers the right to do it and they have to buy that right, then we can use the excess money created to perhaps compensate the people who are negatively impacted, or society as a whole, those social losses. So in this sense, this can also be a just outcome that's fair to all parties concerned. We'll look at how that might work in practice in the next lecture. There is another approach. If we know how much this social cost is, we could add a tax, which is formerly known as a Pigovian tax, I'll speak more about that in the next lecture, that equals the harm. So we add a tax to make up the difference between the private cost and the actual social cost. So this tax will be the difference between the two. And again, we could use this money to compensate those who are being harmed if we wanted to have a just system. Now, again in this system, what we're doing is we're reducing the total quantity produced and pushing up the price because we've changed the cost curve. But, as we saw, this result is actually more efficient than before because we no longer have that large negative externality, that big red wedge that we had before. Now the negative externality is accounted for and can in principle be compensated for as well. Economists have in the past argued that gas prices, for example, in the United States, are too low to account for all these negative externalities, all of these social costs. This goes beyond carbon dioxide emissions. It includes the costs of road congestion and local air pollution. Think of smog in big cities. So Americans consume more petrol than would be efficient. We drive more than would be socially optimal. And if we actually consumed less, we as a society would in fact be better off. Now, residents of Europe and Japan pay about twice as much for petrol as residents of Canada and the United States. And this difference is largely because of increased surcharges and taxes. So you might argue, well, this is a good thing because this is reflecting the true cost. It includes the social cost as well as the private cost of supplying those petroleum products. But we have to remember, of course, that travel is a benefit. That's the demand curve, right? People like to travel, it's good to get around. So, in theory, you can have taxes that are too low. They don't take into account those social costs. But you can also have taxes that were too high. In fact, they restrict the amount of travel too much. So, good policy requires an ability to judge what that correct price is. And that can be difficult to do. To make the policies that would enact a cap or a tax might require information that we don't have. Let's think about the pure market case again. In this case, no one person or one individual or one government is able to say exactly how much should be produced and at what price. That quantity produced and the price per unit is an emergent property of the system, and it's what Adam Smith called the invisible hand. If we want to change that market outcome by adding a cap or levying a tax, we want to be sure that we have a pretty good idea about how much that social cost is. Otherwise, we could be unnecessarily removing the ability of people to find that right price and that right quantity to maximise that social welfare. Examples of how we might make those estimates are in the text. But I want you to be aware that that's not an easily solved problem. Notice that the cap system, which might be an example of a command and control legislation, we have a limit set, and the market incentive system of the taxation approach can actually produce the same result as they did in this example. But both approaches require that we really understand the social costs. So that means we really need to understand what the damage is to the natural environment. I spoke in the last lecture of focusing on the most important problems. And in some ways, we can use this framework as a way of understanding what the most important problems are. Those are the problems that are producing the biggest net social cost. So those are the problems where we have the largest amount of social cost that is not accounted for. So that could be, for example, our energy systems, which is a large part of our world economy, where we have a large gap between what the social cost is and what the private cost is. You might think of many other examples. Some problems have smaller social gaps, or the transactions involved are relatively minor. So we can think about the big problems as both having a high unaccounted for social cost, so there's no legislation that takes into account the damage being done, in conjunction with the fact that this area is a substantial part of our economy. The energy economy is an excellent example of this. It's a very large part of the world's economy, and there's also a substantial social cost. You might be able to think of other examples where there is something that's widespread through society, as well as large amounts of unaccounted for social costs. In the final lecture this week, we're going to look at how these environmental economics ideas have been used to make environmental policies that try and address these imbalances.
Produced by OCE Atlas Digital Media at the University of Illinois, Urbana-Champaign.